Hi, math friends. Today we're looking at angle relations, and we're going to look at some vocabulary and then get started on how these are going to work. Some things that we need to know are straight angle. So a straight angle measures 180 degrees. It's pretty much thinking about a line. In math, we think of it as a line. You might think of it as a straight line in general terms. A right angle measures 90 degrees. And let's draw some of these too. So a straight angle, it might just be like a line like that. A right angle, if we need to remember this, it'll be denoted with a mark here like that. Kind of looks like a square there to show that that's 90 degrees right there. All right, so these are going to come into play with supplementary and complementary. Supplementary is when two angles sum to 180 degrees. Complementary, the other side of that, is when two angles sum to 90 degrees. So if I'm looking at supplementary angles, I might have a line, and there might be another line there. And the supplementary angles here are going to be this angle and then this other angle here. We usually denote different angles with different kinds of marks, like this one is just this arc. This one is an arc with a little tick mark on it. For complementary, so if I have a 90-degree angle, and in math we usually will have things given to us, like we'll tell you that this is 90 degrees, or we'll have the 90-degree symbol, and then they're being separated by another line. So now we'll have one angle here, and we'll have another angle here. So these two purple ones that we marked here will be complementary because they add to get 90 degrees. Let's look at writing and solving equations to solve some of these problems here. So here's our chart, our graph, or our picture of this angle, and our prompt says find the measure of angle DBC. So in math, instead of writing measure of angle DBC, we like to use symbols. So this is measure of angle DBC. So if you're writing this, you can just write M angle symbol DBC. All right, so we need to remember how to label angles and where to follow them. So DBC, I'm going to go ahead and highlight that, D to B to C. So this is the angle that I want to find. So it would really benefit us to mark the angle that we're finding. So I know that this angle right here, ABD, this is 19 degrees. DBC is the one we're looking for. And what do we know? We know ABC, so follow in order, A to B to C is 90 degrees. There's the 90 degree symbol on there. So when I write an equation on there, I'm going to say 90 equals 19 plus, because they're complementary, this unknown angle. I'm going to call that X. You can use any sort of symbol that you want to, but I'm just going to call that X because we don't know what that is. All right, I'll draw my line down the middle, and we'll solve an equation for this. It really helps to have an equation like this instead of trying to just figure it out. If we try to just figure things out, sometimes we'll get them right, but if we have a plan for them, then almost always we'll get them right. All right, so minus 19, so we get X, and then 90 minus 19, we get 71. So then I know that DBC is 71 degrees. And we have to have that degree symbol in there, otherwise it won't make sense. All right, let's try another one here. So again, I look at this picture, and this is WXY, angle WXY, and I see this is 90 degrees, and I see this 80. So this 80 here, this is actually marking for WXZ. So whenever I see that, it stops with this line. And the angle that we're trying to find is ZXY. So if I follow along, if I trace that ZXY, that's this really skinny one right here. I'll call this angle X. And since they're complementary, they had to be 90 degrees. We're going to set our equation again. 90 equals 80 plus X. And then we'll look for inverse operations, minus 80 on both sides of the equation. So I get 10 equals X. When I put that into, what does that mean? That means that measure of angle ZXY is 10 degrees. All right, now let's look at a straight angle. So this one, EFG, straight across here, this is going to be what we looked at before. This is 180 degrees. So this time I have two angles equaling 180. These are supplementary. So 180 equals, and then how do we set up our equation here? Well, let's look at what we're trying to find. EFH, so E to F to H. So my unknown is actually over here. I'll call this X. 71 is on the other side. So I have 180 equals 71 plus X. We should start to see patterns here too. So inverse operation, minus 71, minus 71. We get X here, and we get 109 over here. When we write our final answer, we're going to say 109 degrees. All right, last one that we're going to do is an example today. JKL, so straight across, that's a straight angle, 180 degrees. And we know that this part of it is 100. MKL is what we're looking for. So we'll call that X. And let's go ahead and write an equation for that. 180 equals 100 plus X. Look for inverse operations, so I'll do minus 100 because it's being added to X. And then I'll get 80 equals X. So at the end here, measure of angle MKL is 80 degrees. And remember, we want to write equations and solve them here for finding these. The main reason is because sometimes if we take a protractor and measure these on paper or on our screen, it'll work out nicely. But a lot of times in math, to make sure that we're doing these correctly, these angles won't be measured properly. So, for example, if I take this and I'm going to go ahead and copy that, sometimes instead of 100, like if this is measured correctly, this might just say 70 degrees. And that might look kind of weird because if you measure this, this won't measure to be 70 degrees. But if you go ahead and use the equation, then you can make sure that you're doing it properly. And it might look strange that like this angle will be larger than this one because this just looks bigger. But we have to get used to getting into a process of writing these equations and solving them instead of just trying to figure them out or just trying to look at it.